This question belongs to computer organization subject and the topic name is memory organization. It was asked in GATE 1990. So the question states, in interleaved memory organization, consecutive words are stored in consecutive memory modules in which interleaving, whereas consecutive words are stored within the module in which interleaving. So let me first tell you what an interleaved memory organization means. Suppose we can have memory organization in two ways. We can have memory organization in two ways. First one is like this. Suppose we have RAM, so we will store the entire addresses like this. Suppose we have 256 million addresses. We want to generate 256 megabyte of memory and it is byte addressable. One word equals to one byte. So we need 256 million addresses over here. Bytes would be over here. And how many address bus size will we need? Address bus size and 256 can be written as 2 to the power 8. So we need 2 to the power 28 because 256 is 2 to the power 8 and million is 2 to the power 20. So we need 28 address lines for address bus. This is a normal concept, but here the disadvantage is that when we have consecutive read and write operations, suppose we are reading from address 0, address 1, address 2, address 3, as we have locality of reference, so we will have consecutive reads and writes. So we will have consecutive reads over these addresses. And if we read from address 0 from a memory module, then there is some delay after which only we can perform another read or write. So between 0 and 1 there would be a delay, between 1 and 2 there would be a delay, between 2 and 3 there would be a delay. Now to solve this problem, we came up with this interleaved memory organization. So now I will explain you this interleaved memory organization. So what happens in this is, we will have different memory modules. Let us suppose we have 4 memory modules like this. We have 4 memory modules like this. So what was the total memory? 256 megabyte. It is equal to 2 to the power 28 bytes. So we will divide it equally into 4 parts. So here it would be 64 megabyte, here 64 megabyte, here also 64 megabyte, and here also 64 megabyte. And here what we will do is that we will have 64 megawords of size 1 byte. So how many bits of address lines we have? We have 28 address lines from A0 to A0 to A27, A26 and A27. So what we will do? For 64, how many do we need? For 64 megabyte, we need 2 to the power 6 and 2 to the power 20. We need 26 lines. So either we can have two options. In first case, either we will assign A0 to A25 for this selection. Like let us suppose assign A0 to A25 for selecting the address. It will go same over all the chips, and A26 and A27 will act as chip select. As we are using higher bits, so it is called high order. And in high order, what happens? Suppose we have address like this, A0, A1, A2, then we have A26, A27. So what happens? 0 to, as we have higher significant bit are changing, and it is same for this. For it will be 00 for all the 64 megabyte of this chip. So it will have address from 0 to 64 megabyte. It will have address from 64 megabyte to 128 megabyte. It will have address from 128 to 192 megabyte, and it will have address from 192 to 256 megabytes. So it will have addresses like this. Now what we are doing is that we will have another solution. So the disadvantage of this is, if we are using consecutive memory addresses like from 0, 1, 2, 3 false, due to this delay, we need to have a delay between read and write. And here also, as we are selecting from the same memory module, delay would be there. so it is less preferred. And here 0, 1, 2, 3, all the addresses come in the same memory module. So consecutive words are stored in consecutive memory modules? No. Consecutive words are stored within the module. Consecutive words, 0th word, 1th word, 2th word, 3rd word, 4th word are stored in the same memory module in high order interleaving. Now we have another interleaving which I will explain you. It is called low order interleaving. So how it works is something like this. Let me explain it to you more clearly. Yeah. So we have addresses like this: A0, A1, A2, A3, and then A26 up to A27. So what we will do in low order interleaving? We will use A0 and A1, which means we will use least significant bit. These two bits for determining the chip select logic. They will determine the chip select logic. How it is determined previously also and here also it is determined using 2x4 decoder. And these are used as address lines. These 26 bits are used as address lines. So how address will work? I will explain you this now. Suppose we have bits from A0, A1, A2 up to A27, A26. So we are changing this bit. This bit is fixed for each one. So what addresses will come in the first one? It will have all 00 for this and all these will change. Which means addresses like 0, 2, 0, 4, 8, 12 will come over here, as only this can change. So either this can be 0, then this can be 1, then we can have this, then we can have this, then we can have this, and addresses like 1, 3, 5, 7 will come over here, like 1, 1, 5, mod 4 would be there, 1, 5, 9, 13, and here it would be 2, 6, 10, 14, here it would be 3, 7, then 11, 15, and so on. So consecutive addresses like 0, then 1 over here, then 2 over here, then 3 over here. Consecutive addresses will be stored in different modules. What is the advantage of this? The advantage of this is if we are running a program and we are accessing addresses 0, 1, 2, 3, 4, 5, 6, 7, 8 due to locality of reference, then 0 would be over here, then it will go in some delay, but we can at the same time select 1 from here, then we can select 2 from here, 3 from here, and then again from the module 1 without any delay. So this is the advantage of this. So in low level, consecutive words are stored in consecutive memory modules in low order interleaving. So answer is first fill in the blank is low order interleaving and second one is high order interleaving.